Alright, so this is number 19 from practice test number 2. It involves ratio test, alternate series test, and p-series. Okay, so if you're given this, you want to find the interval of convergence, all x values that it converges to. So the ratio test is when you take the n plus first term over the nth term and find the limit as n goes to infinity, and takes the absolute value of that, and if that's less than 1, whatever values make it less than 1 is going to be values that will produce convergence. So think of it as kind of a geometric series where the ratio of, if you're multiplying by 0.3 every time, that'll converge because the ratio is between -1 and 1. This one may not be exactly a number, but it behaves that way. If you take the n plus first term over the nth term as it goes to infinity, that has to be less than 1. Okay, so in this one, I have x minus 3 to the n plus 1 over n plus 1 squared, 5 to the n plus 1. Then we would divide by the nth term. If we divide by the nth term, we're dividing by this, which is just multiplying by the reciprocal. So I'm going to multiply by the reciprocal of that. And we take the absolute value of it. The n stuff, the absolute value doesn't matter because it's implied that they're positive. So the absolute value is really about the x stuff here. And we're finding the limit as n goes to infinity. All right, so these two are, I have one more x minus 3 term on top. So that's an x minus 3, one more on top, absolute value. And then I've got n squared over n plus 1. We'll partner those up. N plus 1 squared. And then 5 to the n over 5 to the n plus, that's one more 5 in the bottom. So that is a 1/5. Remember, n is going to infinity. So n squared over n plus 1 squared is this. And the ratio of the coefficients is just 1 over 1. So this is just going to go to 1, which it often does. So we have 1/5 x minus 3 in absolute value. It has to be less than 1 in order for it to converge. I can get rid of the 1/5. I'm going to multiply both sides by 5. So I have x minus 3 absolute value less than 5. All right, so at this point, we know what the center of the interval is. It's 3 right here. And the radius is 5. You know that by inspection just because of the form it's set up. But just to be sure, I'm going to say, well, x minus 3 can be less than 5, or opposite of x minus 3 can be less than 5. So x less than 8. Divide by -1, so x greater than -2. So it's between -2 and 8. So on the number line, between -2 and 8, it's converging. So converges here to here. And what's in the middle? That would be 3. That's our center. And our radius would be 5. Okay, we knew that because the center is right here, radius is right there. So center is 3, radius is 5. Okay, so this is just our initial interval convergence. We know it's between -2 and 8, but we have to check endpoints. Okay, it might converge at -2 and it might converge at 8 also. Okay, so checking endpoints at x equals -2. We'll see what happens. So we're plugging -2 in for x. So it's -2 minus 3 to the n over n squared 5 to the n. All right, so now, does that converge? So that's -5 to the n. So -5 to the n, I'll put that 5 to the n underneath it. So this is the same as -5 over 5 to the n. That's one of our properties. So it's -1 to the n, 1 over n squared. All right, so we're doing the sum as 1 goes to infinity. All right, so it does alternate. So checking the alternate series test, 3 criteria. Does it alternate? Yes. Does each term, ignoring the -1 to the n, does each one get smaller? Yes, as n increases, each term will get smaller. And the third criteria is the limit of this as n goes to infinity 0? Yes, it is. So it converges using alternate series test. Okay, so we include -2 in our interval of convergence. Now at 8, we have 8 minus 3 to the n over n squared 5 to the n. So that's 5 to the n over 5 to the n. So that's just 1. So we end up getting 1 over n squared, sum equal from 1 to infinity. Does that converge or diverge? Well, this is a p series because it's 1 over n to some power, where p is equal to 2. And remember, if p is greater than 1, it converges. P is greater than 1, so it converges at 8 also. So our interval of convergence is between -2 and 8, including the endpoints. That's part A, or answer A.